welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your CBNST class, and that has been the classes, your 22th classes of the session. Here we had done your 21th class in the last session as well, and where we had started with unit 1, which has been the computer arithmetic errors and roots of equation. In that, even though we had done many of the method, which has been the second method, Newton-Raphson method, bisection method, iterative method, successive method, many more we had done. Now today we'll start discussing about the attic and accelerations of conversion that we'll have to discuss here. But before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many and maximum people can get the information at once and you can also enjoy the video as well. So here we go ahead. So we'll start with this, and that the question will start with explain Atkin's accelerations of conversion. Explain Atkin's acceleration of convergence that we have to discuss here. For the Atkin accelerations of convergence method that is used to improve the linear convergence of iterative or a fixed point iteration method. Let the desired root be x that is being equals to, and let the three successive approximation for that be xn minus 1, xn and xn plus 1. So for that it will be representing in the form equals to k, and there has been k minus xn minus 1, where minus xn plus 1 equals to k, and minus division of first equation by the second, we get upon equals to k upon minus xn. That will give you xn square equals to xn plus 1 minus xn minus 1. For that, square minus 2 xn plus xn square equals to square minus xn minus 1 minus xn plus 1 plus xn plus 1 xn minus 1. Simplifying the above equation equals to xn plus 1 minus xn plus 1 minus xn square. For the same, and that is we go ahead here upon xn plus 1 minus 2xn plus xn minus 1. On the same phases, that is, let us define delta xn, which is being equals to xn plus 1 minus xn. So then you have your the delta square, then we have your delta square xn equals to delta xn. So for that, hence delta square xn minus 1 equals to delta of xn, and hence that will go ahead delta square xn minus 1 equals to delta xn minus 1. So delta xn minus 1 equals to delta xn minus delta xn minus 1 equals to xn plus 1 minus xn minus xn minus xn minus 1, which is further equals to xn plus 1 minus xn minus xn minus xn minus 1 is equals to xn plus 1 minus 2xn plus xn minus 1. For putting this results in this, then we'll get your value equals to xn plus 1 minus delta xn square upon delta square xn minus 1. For that, this equation gives the Atkin accelerations of convergence process. It is also called as delta square process as well. So we go ahead further, which we'll talk about here itself, and that has been the another question we talk about it. The question is, consider the function x equals to 3 plus cos x obtained a first three iterations x1, x2 and x3 by a fixed point iteration, then obtain the next approximation by the Atkin's delta square process, and you have to assume the initial root, which has been x is 0 is equals to pi by 2. So we'll go ahead for the same. Consider the function x is equals to 3 plus cos x upon 2. Obtain the first three iteration x1, x2 and x3 by fixed point iteration then obtain next approximation by Atkin's delta square process. Assume initial root x0 is equals to pi by 2. That we have to talk about. So for that, here xn plus 1 equals to phi xn by a fixed point iteration, or xn plus 1 is equals to 3 plus cos xn upon 2, since x is equals to 3 plus cos x upon 2. This is being the phi x. For x1, the x1 is equals to 3 plus cos x0 upon 2, which is equals to 3 plus cos pi by 2 a whole upon 2, which will give you the value 1.5. For x2 equals to 3 plus cos x1 upon 2, that has been cos 1.5 upon 2. We'll get 1.53537. For x3 equals to 3 plus cos x2 upon 2, 3 plus cos 1.53537 upon 2, give you value 1.517711. Now let us use Atkin's delta square process following table list out of the final differences we have. We made a table for it. Xn for that, then delta, and of course the delta square. We put the value here. For x1 equals to 1.5, the delta x1 is equals to x2 minus x1, which will give you the value 0.035367, and delta square x1 will give you delta x2 minus delta x1, which is being equals to x3 minus x2 plus x1, which will give you the value minus 0.053023. For delta x2, it will give you x3 minus x2, and the value will get you is minus 0.017656. And for here as well, the x2 is your, for xn that is mean 1.535367, and for x3 is equals to 1.517711. That we have your value. So by Atkinson's delta square process, we'll use the formula here. And that the formula we have here is equals to xn plus 1 minus delta xn square upon delta square xn minus 1. For that equals to x3 minus delta x2 square upon delta square x1, where with n equals to 2 in the above equation we'll put the value, that is being 1.517711 minus 0.017656 square upon minus 0.053023 to get the value 1.523590. that we get as an answer. Now we go ahead with another question that has been we are dealing with in its steps as well. So the other question is your write computer algorithm for bisection method. So हमें computer algorithm लिखनी है for the bisection method here. So we'll do the same. You can just copy it down as well. The question is write computer algorithm for bisection method. So here that we go ahead here and that we have to talk about it. So for the same we'll go ahead here. On the same case that the assumptions we have, the first assumption is that the function fx is predefined. Okay, so we go ahead here in the detail. The second assumption we get here is that is correct value of interval a comma b are entered in which root lies. That we have to discuss here. So for the step we'll talk about here this step. So for the step that is being a read interval, read interval a comma b and permissible error or correct significant digits after decimal point that we have. So now we go ahead for the step 2. So with the same, the step 2 is you have to calculate the number of iteration n using. So we have your n equals to, n is greater or equals to log b minus a minus log e upon log 2. Now in this step 3rd we have to go ahead, and that is being, so in the same case for the step 3. So for that step 3 you have to calculate the center point of an interval, which is b equals to c is equals to a plus b by 2. In a step 4, and that is we have for f(x) x equals to 0, which is equals to fa f(x) x equals to b equals to f of b, and f(x) x equals to c, which is f of c. Now for the next we go ahead for the step 5. For step 5 it will be, if f of a f of c is less than 0, then root lies between a and c, hence replace b by c. Okay, now in step 6, but yes, we have another condition for step 5 as well, that is if f of b f of c is less than 0, then root lies between b and c, hence replace b by c. Okay, that we have here. So now we'll go ahead for the step that has been the 6th here, and that what we have to discuss as well, and that has been important one. But the step 6 we have here is as follows, like, you know, I just write it down because it will be not consisting of formula, so you will be confused what we'll have to do, either it is skipped or not. So I just write it down for the same. So here for the step 6, repeat step 3 to step 5 until number of iterations are reached, or repeat step, for that it will be repeat step 3 to step 5 until value of c repeats up to given significant digits after decimal point. So now we'll go ahead for the step 7 as well, that we have to discuss here. So here the step 7. So for the step 7, approximate value of a root is equal to center point of lattice interval. And on the same phase, we'll go ahead for the step 8, that has been the last. In that, the display approximate value of root and star that we have. So for the same, we'll go ahead for the next questions here, which is write a computer algorithm for the second method. This is the algorithm, the computer algorithm we had written for the bisection method, and now we'll go ahead for the another one that has been the second method for the second method here. So write computer algorithm for second method. So for the assumptions, we here go ahead. The assumptions is that the function fx is predefined here, and that the correct values of the initial approximation x0 and x1 that has been entered in which one root of fx that has been representing here. These were the two assumptions, so I just write it down for you all so that you will get to know about it. So we'll go ahead for first we'll go ahead with assumptions here. The function fx is predefined, okay, that we have here. The second assumption is the correct values of initial approximation x0 and x1 are entered in which one root of fx lies. Now we go ahead for the steps that we have to deal with it, which we had done for the bisection method, that we'll deal with for the second method as well. So yeah, we go ahead for the same. For step 1, for the same, and that has been read intervals x0 x1 in which root of fx lies, and read number of iteration, read number of iterations to be performed. That we have to go ahead. Now for step 2, we'll go ahead here. That for the step 2, in that you have to calculate fx0 is equals to fx x equals to x0, and fx1 is equals to, which has been equals to fx x equals to x1. We'll go ahead for the step 3, that to calculate the next approximation root for that has been the x2s, and that we'll have to calculate it here, which has been x2 is equals to x1 minus x0 upon fx1 minus fx0, that has been fx1. Now for step 4, that has been x1 tends to x0 and x1 that is being tends to x2 for next cycle. The step 5 we have here that you have to repeat a step 2 and step 3 until the last given iterations, or if the number iterations are not given, you have to repeat the 2 and 4. I just write it on it so that you can also write it down and you will make it. Repeat step 2 to step 4 until last given iterations, or if number of iteration are not given, repeat step 2 to step 4 until x2 repeats up to gives number of significant digits after decimal point. Step 6, that we have here is approximate value of the root is equal value of the root is equal to x2 of the last iteration. And now we'll go ahead for the step 7, that is to display approximate value of root and stop. That what we have. So here we're gonna end up with this, and it's a huge request to all the viewers to please go ahead with like, share and subscribe to our channel so that many and maximum people can get the information at once, and you can also enjoy the video as well. Other than this, we had done your sociology and software engineering, and we had done your we had done your ER diagram. We are dealing with English vocabulary as well. And after talking about that, yes, we had done your that has been the reasoning. In that we had done your which is general mental ability in the logic reasoning. And non-verbal reasoning we had done your series analogy, classification, analytical reasoning, mirror image, water image, embedded figure, completions of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, cubes and dice, dot situation, constructions of squares and triangles, figure formation analysis, practice question set, and of course that has been we had done here. So in terms of quantitative aptitude, in that we had done started with arithmetical ability. In that we had done your operations on numbers, SAF and LCF of numbers, decimal fractions, simplifications, square roots and cube roots, problems on numbers, problems on ages, and indices, percentage, and profit and loss we are dealing here. In terms of CBNST, which has been the computer-based numerical and statistical technique, in that we had done your unit 1 we are dealing with, that has been the computer arithmetic errors and rules of equation. In unit 2 we have to cover up the interpolations and curve fitting. Unit 3 we have to cover up the differentiation and integration. In unit 4 we have to cover up the solution of simultaneous linear algebraic and solutions of ordinary differential equation and statistical technique. So here we're gonna end up with, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many and maximum people can get the information at once, and you can also enjoy the video as well. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you. Stay tuned with us, keep supported us as you had supported us till the date, and whatever the subject you require of, you can just tell me in the comment section. I will surely be providing you that. Thank you.